Today in this video, we will talk about OpenGL vertex array. What is vertex array? You may have noticed that OpenGL requires many function calls to render geometric primitives. An additional problem is the redundant processing of vertices that are shared between adjacent polygons with 6 side and 8 shared vertices. OpenGL has vertex array routine that allow you to specify a lot of vertex related data with just a few arrays and to access the data with equally few function calls. Arranging data in vertex array may increase the performance of your application. Vertex array are standard in version 1.1 of OpenGL but were not part of the OpenGL 1.0 specification. How to use vertex array? 3 steps to use vertex array. Activate enable up to 6 arrays, put data into the array, draw geometry with the data, accessing individual array elements, creating a list of individual array elements, processing sequential array elements. Step 1. Enabling array. For example, if you use a lightning, you may want to define a surface normal for every vertex. To use vertex array for that case, you activate both surface normal and vertex coordinates array. The code for it is given as GL enable client state, GL normal array, and GL enable client state, GL vertex array. Suppose that you want to turn off lighting at some points and just draw the geometry using a single color. You want to call GL disable to turn off the lighting state. Now that the lighting has been deactivated, you also want to stop changing the values of the surface normal state, which is wasted effort. To do that, you call GL disable client state for a GL normal array. Step 2. Specifying data. There are 6 different routines to specify array. One routine for each kind of array. Void GL vertex pointer, GL lint size, GL linum type, GL size, constant GL void pointer. Specifies where spatial coordinate data can be accessed. Points is the memory address of first coordinate of GL vertex in the array. Type specifies the data type GL short, GL int, GL float, GL double, or of each coordinate in the array. Size is the number of coordinates per vertex, which must be 2, 3, 4. Stride is the byte offset between consecutive vertex. If stride is 0, the vertices are understood to be tightly packed in the array. To access the other 5 array, there are 5 similar routine. Void GL pointer, void GL index pointer, void GL normal pointer, void GL text code pointer, and void GL edge flag pointer. Step 2. Specifying data, enabling and loading vertex array. Stride. With a stride of 0, each type of vertex array RGB color index, coordinate, and so on must be tightly packed. The data in the array must be homogeneous, that is, the data must be all RGB color values and all vertex coordinate, or all some other data elements must be similar in fashion. Another way is to use GL interleaved array. Using a stride of other than 0 can be useful, especially when dealing with interleaved array. Another way of using GL interleaved array. Step 3, using the content of the vertex array and are different. The array remain on client side and their content are easily changed. In step 3, the content of the arrays are obtained, sent down to the server and then sent down to the graphic processing pipeline for rendering. There are three ways to obtain data. Difference, a single array element, difference. The effect of GL draw element is almost the same as the command. The effect of GL draw element is almost the same as command sequence. GL begin of mod for int I is equal to 0, I is less than count, and I plus plus GL array element first plus I, GL end.